Welcome back to Maths with Mrs. J. In our previous video, we learnt about using tree diagrams to help us list outcomes when we're doing either the same thing several times or different trials of different experiments and we're combining them. Now, tree diagrams are quite useful up until you get to about where we were in the previous one. About 16 outcomes is about the maximum that you want to have to be doing. Otherwise, it's going to be getting quite unwieldy. There is an alternative, but the alternative has a drawback as well. And the alternative is grids and tables, grids or tables. The problem is here, the drawback is that whilst you can have a lot more possibilities for each option, for each trial, it's only two-dimensional. So it can only be two rolls of a die or two tosses of a coin or two children in a family, that sort of thing, or one roll of a die and one toss of a coin. The two-dimensional nature of this is somewhat limiting. However, one benefit is that this tends to be a lot neater. If I tried to do this with a tree diagram, I'd have 6 branches coming out to start with, and then 6 branches off each of those branches, which would be quite a mess, whereas this is relatively neat. Colour coding is again recommended. You don't have to do it, but I find it is helpful. Label whichever one you want to be your first die and you choose a colour for that. So whenever I see pink, I know that that's the number that we got on our first die. And I coloured my second die orange. So whenever I see this one here, 6 in pink and 4 in orange, I know that I got 6 on the first die and a 4 on the second. So drawing up your grids, yes, it's a bit fiddly, but it can really help you answer quite a number of questions about that situation. Again, colour coding is helpful to work out which outcomes are what we would term favourable. In other words, they're what we're talking about. So I would be inclined to, when I'm answering these questions here, do what I did on the previous page, just put probability, do that, being a bit lazy here. It's already written out for us, so might as well use it. And then we're going to colour code each of these events. So let's choose a colour for both of them being the same number. So both the same number, I'm going to use dark green. Okay, let's have a look where these are. So we've got, okay, well that one, they're both the same number. So is that one, so is that one. We can see a bit of a pattern happening here. We're going up the diagonal. So we've got 1, 2, 3, 4, 5, 6 outcomes out of our 36, because it's 6 by 6. So that's 1/6 of the time both dice will have the same number. Okay, let's pick another colour. The sum is 6. Okay. Okay, so we're doing the sum is 6. So let's have a look at some examples of that. Let's see where we can find that. So we've got 5 and 1 would work, 4 and 2, 3 and 3, 2 and 4, and 1 and 5. So all of those ones I've circled in purple will work for the sum being 6. So we've got 1, 2, 3, 4, 5 of them out of our 36, and there's nothing we can do to simplify that. The sum is 1. I'm not even going to bother choosing a colour for this because our absolute lowest sum we have is 2 when each of the dice are 1. So if something's impossible, it has a probability of 0. So that one was fairly easy. All right, the first die even and the second die odd. Okay, let's do maybe yellow for this. All right, first die even and the second die odd. Well, that one will work. That one will work. So will that. So well, that, and that, and that, and that. So how many have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9 out of our 36, which is a quarter. Okay, both dice different numbers. Now, you can choose a colour for this and do this, but this is a bit like on our previous video. We've already worked out the probability that they're both the same number. What do you notice about being both the same number or being different numbers? They are complementary events. They're either both the same number or they're different. So I would actually just do this as 1 minus probability. They're the same. And we've already worked that out in the first question. So it will be 5 on 6. You can, if you really want to, circle all of them, but you're going to be circling everything except the ones that we'd already circled in dark green. There's not really that much point in doing that. So this is where using the complement and knowing that the probability of the complement is 1 minus probability of the event makes your life a lot easier.